Calculus section 7.3 on partial fraction decomposition. We are going to take this fraction and decompose it into partial fractions. As I look at this denominator, it's a quadratic and it's also a trinomial. My goal is to make it into something simpler by splitting it up into two smaller fractions. We're going to rewrite that denominator as x minus 5 times x plus 2 because that's how it factors. Then I want to know, what is this equal to if I split it up into some fraction with the denominator of x minus 5 and also with the denominator of x plus 2. Now, I don't know what their numerators are supposed to be, so I'm just going to create a variable of a and a variable of b. This is really the problem we're looking at now. I want the blue to be equal to the red, and I'm trying to figure out what a and b are equal to. Now, in this fraction problem, I would rather not work with any fractions. So we're going to take everything on the left and everything on the right and multiply by x minus 5. What that does is it crosses off that denominator, and there's nothing to simplify with it in this denominator, so there's going to be an x minus 5 in that numerator. There's still some denominators left, so we're going to multiply everything by x plus 2. We multiply it by this first term, this x plus 2 is gone. This one doesn't have anything to simplify with. And then this x plus 2 is going to simplify out as well. Now, that has been distributed. And on the left-hand side, we have 6x minus 2, whereas on the right-hand side, we have a times the quantity of x plus 2 plus b times the quantity of x minus 5. Not great yet. We're going to do one more step to distribute here. So it's ax plus 2a bx minus 5b. There's three variables. There's an a, there's a b, and there's also some x's in there. But what I know is the amount of x's that we have on the left needs to be equal to the amount of x's that we have on the right. In other words, we're going to write an x equation. 6 from the left is equal to a plus b from the right. And then for the numbers, the left side has -2, and the right side has these. Now, a and b are just numbers, so 2 times this number is a number, -5 times this number is just a number. So as far as the numbers go, the -2 from the left has to be equal to 2a minus 5b from the right. Two equations, two variables. Let's take this first equation and multiply everything on both sides by -2. And what that's going to do for us is eliminate those a's, so then -14 is equal to -7b. Divide both sides by -7, and we get b equals 2. Back substitute this one in. 6 equals a plus 2. Means that a equals 4. So now we can go into writing our equation. It's going to come from this initial part up here. Now I know that instead of just calling it a over x minus 5, it is 4 over x minus 5 plus b, which is 2 over x plus 2. The original problem is decomposed into these partial fractions. All right, we've got one more problem that we're going to decompose into partial fractions, and it looks like this. I see the denominator has x squared times x plus 3, so we're going to write it as a over x plus 3, b over x squared, and if I'm looking at what goes into this denominator, x plus 3 goes into it evenly, x squared goes into it evenly, and I can also divide it evenly by x, so we're going to have a third one of c over x. So it's composed into three different parts now. We're going to multiply everything on both sides by x plus 3 times x squared. When we multiply it by the term on the left, that denominator is completely gone, so it's x squared plus 8x plus 6. When we multiply it by this term, the x plus 3's will simplify out. So we have a times x squared. We're going to multiply this times x plus 3 times x squared. Those x squareds cancel out, so we have bx plus 3b. And then this one is also going to have x plus 3 times x squared. And for this one, I can divide the numerator by x, divide that numerator and denominator both by x. These simplify down. but we still have x times x plus 3, x squared plus 3x times c. So cx squared plus 3cx. All right, x squared equation. We have this on the left, this on the right. We can say that the 1x squared from the left is equal to a plus c from the right. Next, we'll look at the x equation. There's an x, there's an x, there's an x. So as far as the x's go, we have 8x from the left, bx plus 3cx on the right. And lastly, we have the numbers. And from this, we could say that the 6 from the left is equal to 3b from the right. In this last equation, now we know that b equals 2. Substitute it in up here, so then 8 equals 2 plus 3c. Subtract 2, divide by 3, and then c is equal to 2. Plug that in up here. 1 is equal to a plus 2, so then a equals negative 1. So our partial fraction decomposition is negative 1 over x plus 3 plus 2 over x squared minus 1 over x. Plugging in our a, b, c value into the original way we broke it down, and there it is decomposed. One more bonus problem here. We're going to decompose this partial fraction. And what's unique about this one is the degree of the numerator is bigger than the degree of the denominator. And in a fraction like this, it means numerator divided by denominator. And this time we're actually going to do it. We're going to take this x cubed plus 2x squared plus 3x minus 1 and divide it by the x squared minus 4. So polynomial long division. What do we have to multiply x squared to get x cubed? We'd have to multiply it by x. X times x squared is x cubed. X times negative 4 is negative 4x. We're subtracting, so we're changing those signs. On 2x squared plus 7x minus 1. Okay, next. What do we have to multiply x squared by to get this 2x squared? 2. 2 times x squared is 2x squared. 2 times negative 4 is negative 8. Draw the line, change the signs. We're subtracting as we go down. Those cancel out. 7x plus 7. So when we do this division, we get an answer of x plus 2 with the remainder of 7x plus 7 over x squared minus 4. And this is partial fraction decomposition. We couldn't have done it from the beginning. It wouldn't have worked. But now from here, we can decompose this. We're going to say 7x plus 7 over x squared minus 4, which factors as x minus 2 times x plus 2. That's equal to a over x minus 2 plus b over x plus 2. We're decomposing this part. Multiply everything by x minus 2 times x plus 2. It's going to make the denominators on the left side totally cancel out. This a is essentially then going to be multiplied by x plus 2 because the x minus 2's would eliminate each other, plus b times x minus 2. Again, if we distribute this, times x minus 2, x plus 2, x plus 2's would eliminate. We'd essentially get b times x minus 2. Go down with it. So as far as the x's go, we have 7x on the left. We have ax plus bx on the right. Go ahead and highlight. So here's our x's from the left and from the right. So 7 is equal to a plus b. And we leave the x's out of there. We're talking about the equations with the x's, so don't make the mistake of saying 7 equals ax plus bx, which is what I almost did there. And then as far as our numbers go, we have 7 on the left equals, distribute that, 2a plus, distribute that, 2a plus negative 2b or 2a minus 2b. We have an equation. How about we multiply this top equation by 2? 14 is equal to 2a plus 2b. The reason why that's helpful is because now when we add these together, 21 is equal to 4a. The b's cancel out. So a equals 21 over 4. Plug that in over here. So then 7 equals 21 over 4 plus b. We solve that. We get, let's see, take 28 over 4 minus 21 over 4. b is 7 over 4. Now we're ready to write our answer. So from this original problem, scroll up a little bit, that's in black, we did the division, then we decomposed the remaining fraction. So our answer is going to be x plus 2, which was the original quotient, plus a over x minus 2. So 21 over 4 times x minus 2, that's 21/4, our a value, plus b is 7 over 4, so 7 over 4, 7 over 4x plus 2.